Linear regression, algebra 2, trigonometry regions. So linear regression has a lot to do with something called correlation. And correlation is the relationship between two variables. Like in the example I'm going to do here, the table has age and heart rate. So these are two separate things, and they may be related, and I think in this case they probably are, but there's, of course, going to be cases where they're not, but it could be miles a car drives versus the amount of gas that's in it. And it could be things that are completely unrelated. It could be, your favorite ice cream flavor and your height, but it's just two things and you want to know if they're related. And so that's what correlation is there a relationship between them? And there's really three basic types of correlation. There's positive correlation, negative correlation, and then there's just simply no correlation in general. We tend to do scatter plots to illustrate these. So let me draw just a couple of scatter plots here. A positive correlation is correlation that looks like it has a positive slope, right? If we were to draw a line in there, it'd be a positive sloped line. Going left to right, it's increasing. So this is a positive correlation. A negative correlation, you could probably guess, would look like a negative sloped line. And so it's a negative correlation. It's going down when you go left to right. This is a negative correlation. No correlation is when you don't really see any type of linear pattern in it. This is no correlation. And so sometimes the questions are as simple as, given a scatter plot or something, is this positive or negative or so on. So that's just basic positive correlation, negative correlation, no correlation. And you probably knew that. But now we have strong positive, strong negative, weak positive, weak negative, and so on. And that comes up from something called the correlation coefficient. So let me show you 4 more scatter plots. So this one right here versus this one here. Now, this would be a strong positive correlation. You see how it's really tight together, and the tighter it resembles a straight line, the stronger it is. This is a little bit looser, so this would be a weak positive correlation. And same thing for negative. You could have really strong negative correlations. This would be a strong negative, and then you could also have weak negative correlations. So it's not just enough to say that it's positive or negative. Sometimes we want to know its strength. And the way we determine its strength is by something called the correlation coefficient. So the correlation coefficient. I want to make sure I get the spelling right here. I'm terrible at spelling. Coefficients. What I'm doing is I'm looking down here. Correlation coefficient. The correlation coefficient, we use the letter R to represent the correlation coefficient. And the correlation coefficient has to be between positive 1 and negative 1. So your correlation coefficient is between negative 1 and positive 1. Like your correlation coefficient is, I'm going to say never something like 2. That's why I wrote 2. So between negative 1 and positive 1. Your correlation coefficient is never going to be beyond that limit right there. So like a strong positive correlation, that would be something like positive 0.9. Now a 1.0 means that they fall exactly on a straight line. And you're not going to see that unless they are exactly in a line like that. But so there's always going to, 0.9 is a very strong positive correlation. A weak positive is something like 0.6. So the closer it is to 0, the weaker it is. And a strong negative is strong, but in the negative way. So a strong negative would be something like negative 0.9. And a weak negative would be something like, again, negative 0.6. So the closer to 0, the weaker. I'm going to write that down, actually. I like that. Closer to 0 is weak. And one thing here is comparing like these two. This is positive zero point 0.6, negative zero point 0.9. This negative zero point 0.9 is stronger than positive zero point 0.6 because strength has to do with distance from zero. We don't care if it's in the positive or negative direction, but how strong is the correlation? Because if you have a strong correlation, that means there's a strong relationship between the two variables you're measuring. Sometimes you want a negative correlation. It doesn't always have to be. Positive doesn't necessarily mean good here. Strong means good. So further from zero, the better. And this will mess up students a lot. There'll be a simple question. I'll give you like a couple of scatter plots like this, and they'll say, which is the strongest? And people will tend to favor the positive one because they think positive is stronger than negative. Not the case when it comes to statistics and correlation. It's just how tight are the scatter plots? How closely related are your two things here? So a negative can be stronger than a positive. That's really the important thing that I want to get through there. All right, so for this question right here, they're giving us this data, and they want to know, first, write the equation of linear regression. Linear regression, you did in Algebra 1. It's also known as the line of best fit. Basically, it's the equation of the line that would sum up the data. All right, but then we also want to know the correlation coefficient. First of all, our calculators need a certain setting for this to work. And what we have to do is we have to turn our diagnostics on. Some of you could get it through mode, but some of you can't. So let me show you one way that you can all do it. If you hit second, 0 brings you to the catalog. Catalog is excellent because it has everything. If you forget where something is, go to the catalog. Like if you have to do DMS for degrees, minutes, seconds, you don't remember that's in second halves, go to the catalog. It'll be there. And then in the catalog, you could hit alpha and hit to the alphabet to jump to places. So hit alpha D, and sometimes you have to hit it twice to jump to the D's. Or you could just scroll down to get to the D's, either way. However you get there, go down to the D's and go to where it says, went too far, diagnostic on. Because you want to turn the diagnostic on. Select that, hit enter, and all it says is done. Basically, now we'll get some extra stat information when we do our problems. You want to make sure that's on. If we're doing a problem and you don't see R, that means your diagnostics are not turned on. So you got to do that. That's one of those things we tell you, like when you sit down for the Regents and you reset it, we're going to say, all right, put it on degrees, put it on A+BI form, and turn your diagnostics on. I have no idea why it's not always on. It should just always be on by default, but it's not. All right, so first thing we do is we do stat, enter, and we're going to type this information in. Now, the first column we're going to type into the L1 column, the second the L2 column. So we got to put that in there. I have numbers in here, so I need to delete them. I'm going to go up to the title, hit clear, enter, that zaps them. Okay, and then I'm going to put these in, 20, 25, 30, 35, 40, 45, and 50. So these are going up by 5. And then the target heart rate is 135, 132, 129. Definitely take your time with this. You don't want to miss any or type one in wrong, so that'll throw all your information off. Make sure you have the same amount each one. All right. Next, stat, and then over to calc. And this time, I want to go down to where it says line reg AX plus B. There's also another one similar to that if you go further down, number 8, line reg A plus BX. I'll be honest, I have no idea what that's for. Maybe somebody who teaches a statistics course would know better than I would. But we want the AX plus B one. So that's number 4. So if I select that, my model has this here, X list, Y list, frequency list. I want this to be blank. If that says L1 or L2, clear that. Now, this is not a frequency table. These are two separate variables. And then I'm going to hit calculate. Now, if you don't have this screen on your calculator, which if you have an older calculator, then you won't, what you actually will need to do is you'll need to type L1 comma L2 and then hit enter. And the way to do that is if you, where's the L1, L2? They're here in blue. So if you hit second 1, comma, second 2, and then enter after you choose linear regression. That'll do it for you. And if you have one of those calculator models, I can show you in class what I'm talking about. All right, so here is the information the calculator is giving us for linear regression. Make sure you're rounding properly here. Since the nearest hundredth, that's 2 spots deep, I need A and B. Don't forget the y equals. You will certainly lose a point every time they ask for an equation you don't have y equals. A is negative 0.66 x, because it's ax plus b. There's my ax. Plus b is 148.54. It'll round to 54 to the nearest hundredth. So there's my equation. So you just round a and b according to what it says. Don't forget the y equals, things like that. And then our r value is right here. This is your correlation coefficient. And so this is a very strong correlation. Negative 0.999. That's it. And that's what it was asking for here. So it's going to be still typing stuff into our calculator, but interpreting different types of correlation and the strength of that correlation. All right, see ya.